everyone, this is a video for uniform distribution and working through some practice problems dealing with uniform distributions. So I'm going to be working off of this distribution here, this uniform distribution, U 1.5, 4.5, and then going through most of the problems that we see here from 16 to 24. Okay. So working within uniform distributions as far as what kind of questions can we be asked about them, what do we know, and how do we work within the formulas that we were given from the last video. Alright, so starting off, so number 16, what type of distribution is this? Well, x tilde u, this is a uniform distribution. Okay, we'll go to 18. What is the height of f of x for the continuous probability distribution? Okay, well, we look back in our notes and we know we have a formula to figure out f of x. Well, f of x is equal to 1 over b minus a. Okay, well, we look at our distribution here and we see, okay, well, a is equal to 1.5 and b is equal to 4.5. Oops, let me back up. B is equal to 4.5. Okay, so if f of x equals 1 over b minus a, then for us that equals 1 over b is 4.5, a is 1.5. 1 over 4.5 minus 1.5 is 3. So f of x is going to equal 1 over 3, or 1/3, or 0.333 forever. So that's how we find the f of x. Use our formula, plug in our a and b, which we get from our distribution here. Okay, all right, let's go to the next one. Let's trash that. Okay, 19. What are the constraints for the values of x? Well, that we go back to what we know about our distribution. We use our a and we use our b. So the left endpoint of x is 1.5, and the right endpoint of x is 4.5. So that's it. That's our constraints for the value of x. For 20, graph p of x between 2 and 3. Okay, so let me do this big. So here's our graph. We know our f of x is 1/3, so we know the height is 1/3, which we figured out from problem, was that 18? So our height is at 1/3. Okay, it's a uniform distribution, so it looks like a block. We also know that our left endpoint starts at 1.5, and our right endpoint ends at 4.5. So graph the probability that x is between 2 and 3. Well, that's 1.5, so that's, I don't know, I'm just guessing, that's probably a 2 right there. And 3, we'll put 3 right here. So the graph of p being between 2 and 3 is simply the shaded area between 2 and 3. So that would be the graph of p of x between 2 and 3, simply just the block. Alright, now 21. Now we actually get to calculate. So what is the probability that x lies between 2 and 3? Okay, well, that is simply the area of the shaded region that we have created. So area equals base times height. My base here is 1 because the distance between 2 and 3 is 1. My height is 1/3. 1 times 1/3 is 1/3, and as a decimal it's 0.333 forever. Okay, so the probability that x lies between 2 and 3, just the area of the block, 0.3 repeating. So that's 21. 22 is a conditional probability, and I'm going to start from up top because we need to remember. So this is asking, what is the probability that x is less than 3.5 given, the bar is given, that x is already less than 4. So if we use our conditional probability formula, p of a given b is equivalent to p of a and b divided by p of b. Okay, so there's our formula. Let's go ahead and fill in our pieces. So probability, so if we look at the numerator, probability of a and b is equivalent to the probability that x is less than 3.5 and x is less than 4. So graphically, what does this look like? Well, graphically, this looks like, so here's our distribution again. Start at 1.5, goes to 4.5, height of 1/3. Let's make that a 3. So there's our block. Okay, and let's use some different colors here. So x is less than 4. Okay, so there's 4. The probability that x is less than 4 is that region there. The probability that x is less than 3.5. Oops, and I realize I keep putting 3.5. Ignore the decimal in front. X is less than 3.5. Let's see, we'll let 3.5 live here. So probability x is less than 3.5 is the blue. So the probability that x is less than 3.5 and x is less than 4 is the intersection. So it's this block of blue and yellow. So P of A and B is in fact this block here, which is also simply the same block as just P of x less than 3.5, okay, the intersection block. So our numerator is simply, I keep putting that decimal, 3.5. Okay. Our denominator, P of B, well, what is B here? B is always the second thing. So B is x is less than 4. So probability of B is probability of x is less than 4, or probability of our yellow block here. So probability that x is less than 4. So this is what we need to figure out here. Let me kind of keep dropping downwards. So probability that x is less than 3.5. So base times height. So our base is between 3.5 and 1.5. So that is a distance of 2. And our height is 1/3. So that's the area of the blue-yellow mix block. Probability that x is less than 4, that's the area of the yellow, so all the yellows. So the length or the base of our yellow block is between 4 and 1.5. So that's a distance of 2.5. And our height is still 1/3. So, conveniently here, our 1/3s are going to cancel. So this really reduces down to what is 2 divided by 2.5. And if you put that in your calculator, you would get 0.8. So what is the conditional probability that x is less than 3.5 given that x is already less than 4? Your answer here is 0.8. And that's probably going to be the longest and most involved problem that you guys have that doesn't necessarily come straight from a formula. The key thing here is the conditional probability formula, so recovering that, finding the intersection space of A and B. So for us, we found the intersection of x less than 3.5 and x less than 4, which is the blue and yellow block. So we found probability of that block, which is just the area of that block, which was 2 times 1/3. And then we said, okay, well, our denominator needs to be P of B. Well, our B in this case is the second thing in the conditional probability. So P of B is probability that x is less than 4, or just the area of the yellow block. Well, that base was 2.5, and that height was 1/3. All right. So we did area of the blue-yellow block divided by area of the yellow block, which became 2 divided by 2.5. The 1/3s canceled. 2 divided by 2.5 is 0.8, and that's how we got our answer. All right, more simply, so 23, what is P of x is equal to 1.5? And I don't care what your distribution is, as long as you're in a continuous distribution, which we are, P of x equals any number is always 0, right? If we're not looking at an interval, it's 0. We have no area here. This is probability of a point. This is area of a line, which has no area. So always, probability of x equals number is always 0. So 23, 0. 24, so this is going to be a little more involved one as well. So 24, we need to check. Let's see, where's the pencil back? So 24, we want to know the 90th percentile, and this uniform distribution is done for square footage of homes, which isn't that important that we know. So, but how to find the 90th percentile? So again, we know our height is 1/3 because that was our f of x that we found in what number? That we found in 18. So we still know our height is 1/3. We know our rightmost point is 4.5 and our leftmost point is 1.5. So what number 24 is asking? Number 24 is saying, okay, well, where would I need to stop on this block? Like, where would I need to put a kind of an endpoint here such that when I fill in this area, I get, so my area of my blue equals 0.9. That's what finding the 90th percentile is. It means what marker do I need here such that my area will then become 0.9. So whenever we're trying to figure out, okay, well, what spot do I need to find? We're going to give it a variable, so we'll give it the variable k. So what does k need to be so that the area is equal to 0.9? Okay, well, area is equal base times height. So the base here would be whatever k is, minus 1.5 times the height. The height is 1/3. So that's the area, and we know the area needs to equal 0.9. Okay, well, let's go through. How do we get rid of the 1/3? So how do we ever get rid of a fraction? We multiply it by its reciprocal. So this gets multiplied by 3/1. This is also going to get multiplied by 3/1, or better word, just 3. So these guys are going to cancel. So I just get k minus 1.5. 0.9 times 3 is 2.7. Now I'll get rid of the 1.5 by adding it to both sides. Back to blue. And we finally figure out that k is equal to 2.7 plus 1.5, which is 4.2. Okay, so which means, so this is going to be 4.2, which means if we draw a marker or an endpoint at 4.2 and then fill in the area, the probability that x lies between 1.5 and 4.2 is going to equal 0.9. So that is precisely what the 90th percentile means. It means what marker do I have to draw down such that if I fill in the area, I get 0.9, because 90th percentile, 0.9. So the 90th percentile here is going to be at 4.2. Remember, percentiles are markers in the data. So the marker that would be the 90th percentile here would be 4.2. So I hope that was helpful. If you guys still have further questions, please don't hesitate to ask. But yeah, I hope that was helpful. I'll see you guys in